Okay, y'all, today is the day. I've built my model. I studied my data. I've made my pancakes. And today we're going to do it. We're going to submit these pancakes and the recipe to the International Pancake Competition. Wish me luck. Listen, the suspense is getting to me as well. But before we find out how my machine learning pancakes did at the International Pancake Competition, I want to let you know that this video corresponds with the random forest lesson on Kaggle's Intro to Machine Learning. I used my decision tree model to come up with what I thought was going to be an incredibly highly rated recipe. I mean, I wouldn't have been surprised if I got a 9 or 9.5, and a 10 wasn't out of the question, but the judges gave me a 7.5. And a 7.5 isn't bad, but I really thought that my recipe would do better. So what happened? Well, when we work with decision trees, we've considered all of our features and built a relatively good model that lets us look at the value in a leaf and then trace our path backwards to figure out which components of the pancake recipe we should include and in which amounts. And that's great. That's highly interpretable, but it's not necessarily highly accurate. If we want to increase the prediction accuracy of our model, we can use something called a random forest. Now, instead of taking all of our features and combining them into one tree, a random forest is going to do thousands of trees, if not thousands upon thousands of trees. And it's going to randomly select which features or variables it's going to pull into a given tree. And then it's going to take all of these trees that it's done with all of its random variable selection, and it's going to average it out together in order to give us our final model. Now, this is going to give us generally a much higher prediction accuracy, but it's become a little bit more difficult to interpret. We can't just look at the leaf on the bottom of our tree, trace our way backwards, and figure out everything that has gone into building that model. And that's okay. In machine learning, there's often a trade-off between prediction accuracy and model interpretability. And that's something you're going to learn a lot more about as you continue in your machine learning journey. So just as a forest is made up of many individual trees, a random forest model is one that's built up of many individual decision trees whose features are selected at random. Let's take a minute and review what the basic pieces of code are for us to kind of build our model. So we define a model. That's where we say, hey, I want to use this model. We fit our model, which is where we train our model on a training data set. Then we make predictions using our validation data, and then we want to validate our model. And in this lesson series, we're validating our model using the mean absolute error. So take a second to think about this. We've created a decision tree model using decision tree regressor. What might be different between the code for a decision tree and the code for a random forest model? Let's take a look. Now, what we decide to call our model is up to us. Here we've called it a forest model. So yes, technically that's a change, but really the meat of the change comes in the model that we've defined. And here, instead of decision tree regressor, we've got random forest regressor. So we've defined our model, we fit our model, made our predictions, and now we're ready to validate our model using the mean absolute error. Let's compare the mean absolute error for our random forest to the mean absolute error for our decision tree. And when we do that, we see that the random forest gets a lower mean absolute error compared to the decision tree. So we've already improved our model by moving from a decision tree to a random forest model. Between everything we've covered in this video, as well as the material on the Kaggle Learn Intro to Machine Learning Random Forest module, we've got two main points I'd like to make sure we recap. One is that the random forest model uses many trees and makes a prediction by averaging the predictions of each of the component or individual trees. And two, the random forest model generally has much better predictive accuracy than a single decision tree, and it works well with default parameters. We've majorly leveled up our machine learning skills. We've gone from building a model using a decision tree to building a model using random forests. And there's a lot we can do with random forests, but for now, let's make sure that we complete the coding exercise in the random forest module as part of the Intro to Machine Learning series on Kaggle Learn. It'll be great practice to apply what we've just learned. And when you've completed the coding exercise, meet me in the next video where we're going to learn about machine learning competitions. Machine learning competitions are a really fun part of the Kaggle platform, and I can't wait to show you how to get started.